This lesson is on the construction of a survivorship curve by Dr. Macrina T. Zafaralla of the University of the Philippines Open University.
Good day. A survivorship curve refers to the linear representation of the rate of survival of a particular group of organisms during a particular point in its lifespan when plotted on a graph. The curve tells the actual number or percentage of individuals that will survive at different ages, beginning from birth to any determined time of increment, like yearly, every 2 years, every 10 years, or every 25 years, depending on the life duration of the organism. Plotted on a graph, the maximum lifespan factor, or simply age, is noted on the horizontal x-axis, while the survival rate factor is on the vertical y-axis. Now, you can have a graph on which to plot the different survival rates of individuals in a particular population. There are 3 types of survivorship curves which apply to different organisms. The first is called type 1. Organisms belonging to this type live their full life expectancy. This curve starts from the far left at the highest point on the survival rate axis, or y-axis, then proceeds as a plateau that very slightly slopes to the right as age progresses. This then drops significantly towards the age of maturity at the far right-hand end of the lifespan factor, or x-axis. The slight plateau shows how, at the younger stage, individuals have a high tendency to survive because of the presence of parental care until around early adulthood. Type 1 organisms have a comparatively smaller number of offspring. The young are fed and even taught how to hunt, are protected from predators, and are given the necessary care and medication in case of ailment. The drop in the number or percentage of individuals may be due to natural causes or diseases. Man, and basically almost all other mammals, belong to this group. Type 2 is applicable to organisms that lay a clutch of many eggs or release their young by spawning. The curve is basically a line that extends from the highest point down to the lower right end of the x-axis. The organism displays a more or less constant rate of diminution through life because the lack of parental care exposes the young to predation and starvation, among other things. This type holds for aquatic organisms that release their young in huge numbers to the environment during birth, and they are immediately caused to fend for themselves for the rest of their lives. Type 2 organisms include frogs, crustaceans, mollusks, turtles, mussels, alligators, birds, rodents, rabbits, and grasses. Type 3 survivorship curve is seen in the organisms that give rise to a clutch of a few individuals, like birds. The curve begins from the highest point on the y-axis, down, but almost immediately drops to the right. But at about the center of the drop, the curve is held to an almost constant slow draw to the right end of the x-axis. Organisms of this type enjoy parental care, are fed the right amount of food, and are protected from predators. Only about 3 or 4 individuals are given birth to and are hid in a protected area away from predators. But due to the natural tendency of the young to get out in the open, they become visible to predators, which wipe out a relatively large percentage of them. The need for the parents to leave the young while in search of food also opens the ladder to their predators. Examples are the eagle, leopard, and the lion. By looking at the survival rate, you can tell the history of the organism and be able to predict its life cycle expectancy. Thank you and good day.